So in this lesson, we're going to look at the tangents and the equation of normals on our line. So just to recap what we'd done these earlier when we did linear and that. So a tangent is when you have see this is the blue one, it's the straight line, and it's the straight line that's connected to the point, say there. See, there's a point on that red curve. So we're going to get the red curve line, and then if they said find the tangent at that particular point, so we might be looking at that particular point, you know, x might equal 2 or whatever. So we'll find the tangent then. So what you need to realise is at that point on the curve, it will have a gradient. You know, we could find the gradient, and how can we find the gradient? We use the derivative. So we could find the gradient at that point on the red line by using the derivative. Now, if the gradient at that point becomes the gradient of that blue line, because that's a straight line, isn't it? And it just has the same number all the way through, doesn't it? Yeah? So we can get the number, and then we would know what the gradient is. Now also, you know, remember when we find a straight line, the formula, we know how to get the gradient now. The way we would get the C value is we would need a point. And so what happens is they've often given you that point anyway. They might have said x is 2 and y is 4. So we'll use that point. So we're going to see that. Now the other one we've got to remember is the normal. Now the normal line is the line that it'll intersect there, so it comes straight out, and it makes it's perpendicular, to the tangent. So remember, we have to remember when we have down here perpendicular lines, if you multiply the gradient of a normal with a tangent, you'll get -1. So we know we'll be able to use the gradient. We can find the gradient at that point by using the derivative rule. So that's where we're going to head. So you've already written this one out, so let's have a look at it anyway. So it says find the equation of the curve y equals 2x squared at the point, so you've got to find the tangent at x equals 1. So just to give you a visual of maybe what was happening there, so we have our normal equation line. So this was the y equals, say, 2x squared, yeah? And then they're saying when x equals 1, so say that's 1, you're going to find that tangent line, okay? So because we're going to find the equation of the tangent is a straight line, so we'll have the y equals mx plus c. So first of all, I'm going to find the gradient. So I'm going to use the derivative. So over here, we've done that. So the equation was y equals 2x squared. So when I found the derivative, wasn't it 2 times 2 is 4? So I have 4x. So can you see there's the derivative? So I want to know the gradient at the point x equals 1. So that means I put x equals 1 into this formula. So 4 times 1 is 4. So now I've got this much of that tangent formula. I know the gradient, so I know that m value. But this is what I was talking about. We don't know what c is. Now, because they said, and we want to know at x equals 1, and we need a point, well, we can use the same point. We know x equals 1. Now, to get the y value, we just put 1 into this formula, this original formula. So there's what I've done. I've put x equals 1, and I found into that original curve, and we find out that y would equal 2 if x equals 1. So that means I can use this point here now to help me find c. So using that point, remember that's an x and that's a y. So I write 2 equals 4 times the x, which is 1, plus c. So I'll rearrange that and I've got the c. So now we've found the whole equation for the tangent. Okay, so that was that one there. This one, so we went again, it said it was just the tangent. So you would go through the whole process again, but this time they helped us. We don't have to go find the y value. They already gave it to us in the same spot. So to get the gradient, I'm going to find the derivative of this. So over here, this is a chain rule. because we've got two functions. So we've decided to call this u and that v. So you can see here, u, I'll find the derivative of u, which is 2 times x, 2x. Then I've got v, which is x minus 2, and the derivative of v would be just -1. So here's the product rule. So you've got to do v times u, so that's where I'm doing that, and then u times the derivative of v. So we do all that, multiply it all out, which I've done there, and you simplify. And there's the rule for the gradient. So I need that, but I want to know because of, it's at 1 up here, so I'm going to put 1 into the formula. And I find out that the gradient is actually 1 for our tangent. So there's the m value, and I need to use the c, but they've already given me the point, so I'm going to use that. They gave me that at the start, and I'll use that to get the c, and overall there's the equation of our tangent. All right, so there's 2 tangent questions. Hopefully this one is a normal good. So we're going to do the normal question here. So find the equation of the normal. So remember, you might want to remember, so you underline that and write that is perpendicular to the tangent. So these are things that you should be thinking about. So then you know, all right, the gradient of the tangent times the gradient of the perpendicular should equal -1. All right, so we know how to get the gradient of the tangent. So the gradient of the tangent, I'll write it down so you can remember, is equal to, you use the derivative of curve at that x point. Yeah? Alright, so here, so we've got, if I was going to find dy dx, so of this function here, so we've got another, it's another product rule really, isn't it? So I might call this u and that v. So u equals x squared. What would the derivative of that one be? 2x, yes? And v equals, I'm going to say x minus 3. So dv equals 1. So these are going to be multiplied together because that's what the product rule says, to do v times du times u times dv, like that. Okay, so we would have x minus 3 times 2x. I'm going to put the 2x at the front because that's how it would probably look. Okay, plus u, which is x squared, times 1. So I'm not going to really put, or I'll put it there so you can see. So it's times 1. So if I expanded that out, that'd be 2x squared minus 6x plus, I had another x squared there. So I end up with 3x squared minus 6x. So that is the derivative, which is the rule for the gradient on that curve at any time. So what I'm going to do now is, because I want the gradient of the tangent, so dy dx when x equals, and I'm going to use that one because they said at point when x equals 1. So I've got 3 times 1 squared minus 6 times 1, which would be 3 minus 6, which equals -3. Okay, so now we're heading into doing the we've got the, sorry, that's the gradient of the tangent equals -3. So now I want to get the gradient of the perpendicular or the normal. So I'm going to go -3 times, do you want me to call it n or p, whichever, the normal, should equal -1. So what is it? If I rearrange that, that will be positive 1/3. Is that true? You bring that over, it'll divide, and a negative divided by a negative will be a positive. So the perpendicular, so you've got your original curve might have been a cubic, like that or whatever. Then you had your tangent, say it was there, which is just making that up. Then you got your perpendicular. Your perpendicular is still a straight line, so it's still mx plus c. And they're all using that one point. So it still means I can use this point they gave me up here in that. So I know that the gradient's a third plus c, but I need to find c, so I'm going to use the point they gave me. So it'd be negative 2 equals 1/3 times 1 plus c. So really it's going to be negative 2 1/3 equals c. And I'll probably change that to be a fraction. That's an improper fraction there. That's not really good. We don't want that. So I'll tidy it up and I'll have y equals, and we probably see it instead of a third x like that, and I'm going to say minus 7 on 3, because wouldn't that be 2 1/3? Yeah? And there's your line to your perpendicular. Okay? Just a quick memory back to things like this. You know, sometimes they put it and they don't have fractions. So if they were getting rid of all those fractions, you might see that formula written as 3y equals x minus 7. Yeah, I'm just timesing everything by 3 to get rid of the fraction, and you can do that. Yeah, I'm not saying this would be right if you did that, but you know when you have a multi-choice, or they might say show that it equals that, and you're thinking, well, mine doesn't look like that. Yeah, because they can rearrange this one as well and they might have you know, have it written, they might have 3y minus x equals negative 7, or, you know, all readjustments of that. But just so you know, I'm just saying you so you know. All right, let's do this one. I'll go back, so don't stress. Find the equation of the tangent and the normal. So we want the tangent and the normal to the curve, so here's our equation. At the point where the tangent is parallel to this equation, this straight line. What does parallel mean? Same gradient. Good. So they're good things to think about, because sometimes you think, oh my God, what am I doing? I don't know. So we know parallel has same gradient. So you know what the gradient of the tangent is, don't you? You know that the gradient must be this gradient, yeah? Because it's the same. So gradient of the tangent is 5. Now, and they're saying at the point when it's 5. So what you really are saying, you need to know, you're trying to find when does the derivative, or dy dx, equal 5. So when does, or what is the x that gives that? Because we need to know at what point it is, yeah? So let's go find dy dx. This one's an easy one to do because it's no product rule or chain rule. So we've got 6x minus 7, yeah? Now we want to know when does that equal 5. We're trying to find what. So I've made it equal 5. So I'm taking this 5 and putting it here, yeah? Okay, so rearrange that. It'd be 5 plus 7 equals 6x. So what have we got? We've got 12 equals 6x. So 12 divided by 6. So it's when x equals 2, yeah? mt, the gradient will equal 5. So how will I get the y value for the point? Because we need to know, we know the gradient of the tangent, but these guys they're straight lines, aren't they? So we need a point. So I'm going to have to get the y value. So into our original equation, this one, I'm going to put x equals 2 to find out what y would be. So it'd be 2 squared minus 7 times 2 plus 2. So that will be, what's that? It's going to be 12 minus 14 plus 2. What's that? 0. Good. So we know the point the point we need is 2, 0. Okay, and now let me go find my equations. So the tangent one, I'm doing in blue. So the tangent at the moment I know is 5x plus c, and I'm going to use that point. So 0 equals 5 times 2 plus c. So negative 10 equals c. You happy with that? So therefore the equation of the tangent is 5x minus 10. And now I'm going to go find the normal, which is like the perpendicular. So to get the normal gradient, I know if I times it by the gradient of the tangent, it always equals negative 1. So you know that this is 5 and this is negative 1, so the gradient of the normal is equal to negative 1 over 5. And so once again, we've got this much of the equation, and I'm going to sub in that point again. So 2, 0. So I've got 0 equals negative 1, 5 times 2 plus c. So c ends up equaling 2 over 5 for this one. And so the equation is 1 equals negative 1 over 5x plus 2 over 5. Okay, and you've rearranged that.